good morning, and we'll begin. Sorry for the delay. So, this today and next week, we will be doing some kind of examples of exploratory data analysis using different data sets. So, this is, again, I'm going to continue using this TripAdvisor data set, which looked at Las Vegas hotels and their reviews and things like that. So we're gonna continue working with that. I've got a couple more examples, or we didn't actually finish the entire analysis on Monday, so I wanted to kind of go through a little bit more. I've got a couple other operations that we'll do, and then on Friday I'll probably pick one of the actual student groups to do, and then we'll do similar things on Monday and Wednesday of next week as well. And then I've met with a few groups yesterday, and so some interesting data sets. And again, anytime I meet with a group, I will just ask a bunch of questions. Ask, did you think about this, or do you have all the data you need, things like that. What do certain variables mean? And it's just to help you start thinking critically about your data sets. And if there are particular operations that you want to do and you think is possible, or you just want to know if it's possible, don't hesitate to ask. If I think it's relevant and something that the class could benefit from, I will happily try to incorporate that into a future demonstration, or if it's something that pertains just to your group and probably doesn't expand to others, I'm happy to kind of help you through that during office hours as well. So I don't want you to feel like I'm just throwing you into the deep end and leaving you there. Okay, certainly this the intention of the final project is to give you this very open-ended opportunity where you can go and dig and ask questions and search for answers as you see fit, as you want, which is going to be an important skill. It's not something I can kind of directly teach you by just doing stuff for you, but it's something you kind of have to you have to start asking questions and searching for the answers yourself. So that's a big part and a big goal of the final project. And again, chances are you're going to have a question and you're not quite sure how to handle it. And so I want to encourage you to come to office hours. To be honest, I'm a little bit surprised at how few students have come to office hours. I tried to make myself available frequently throughout the week. And so, I don't know, maybe I just picked a bad time or in scheduling them or whatnot. But I hope, more students, more groups will come and ask questions, and I'm happy to help and provide guidance. Okay. Anyway, let's pick up from where we left off on Monday. One more thing. I've posted homework 3, and so homework 3 will deal with kind of reshaping data. There's a couple questions from the chapter on ethics, and then there's just a kind of an open-ended exploratory data analysis exercise in the homework, where you're going to take a look at this data set about diamonds. Okay, so like the gemstone that we put in rings and stuff. A data set about diamonds where it asks you to kind of just investigate the distribution of values for some of the variables in there. And that's an open-ended thing. So homework 3 is up, and you can take a look. Okay, again, I'm going to just go ahead and read in the data that we have, which is this Las Vegas TripAdvisor's data set. And I'm going to just kind of go and run through each of these code chunks. One of our code chunks cleans up the variable names, which I think in general I recommend, but again, it's optional. And so what we've done so far is we said, hey, what is the average score for the hotels? We said, there's different classes of hotels. There's 3-star hotels, 4-star hotels, and 5-star hotels. And what's the average review there? We created these plots, and we on Monday we discussed how just going with a point plot, that's not going to be helpful. And so you can do things like add jitter to your plots. You can do things like create a count plot where the circles are proportional to the number of observations in that thing. Box plots are also helpful, but in this particular data set, because the reviews are discrete, where people can only leave 1-star, 1-point reviews, 2-point reviews, 3-point reviews, 4-point reviews, or 5-point reviews, it's not as helpful in this case with a box plot. If you had some kind of continuous variable where it was like, how much money something costs, and you can have different values like $2.51, $2.58, like how much does a gallon of gas cost? $5.49, $4.87, $3.65, whatever it is, and you have this huge spectrum where you don't have a ton of values at the exact same location, and obviously there will be some values at the exact same location, but it's not going to be as as blatant as it is in the case of the hotel reviews. Then a box plot might be better there. On Monday we also said, what if we want to compare the mean scores of the 3-star hotels with the mean score of the 4-star hotels? Well, in order to compare the means of two different groups, we can run a statistical test known as a t-test, where you're going to compare the mean of one group with the mean of another group. And in order to perform that operation, you have to extract the values, and that's what these commands do. It extracts the raw values for all of the reviews for the 3-star hotels. It extracts all of the raw values for all of the review scores for the 4-star hotels, and we're going to put these numbers into the t-test. And so when we did that, the t-test spits out a p-value. And the way we make conclusions regarding these hypothesis tests is we ask, is our p-value large? Is our p-value small? If the p-value ends up large, that means the data we have could have been the result of random chance, and it's not that weird to think of it as being the result of random chance. Okay? Think of it as flipping a coin 20 times and you see something like 11 heads. Okay? Getting 11 heads out of 20 flips is not a weird thing to happen by random chance. And so if that happens, you would have no reason to doubt that your coin is unfair. It doesn't prove that the coin is fair. It is technically possible that you do have some kind of biased coin that lands heads slightly more often than tails, and you got 11 heads out of 20 flips, which is slightly more than 50%. But also, getting 11 heads out of 20 flips is a perfectly reasonable thing to happen with a fair coin, and therefore, if that happens, we don't have any reason to doubt that it's a fair coin. Similarly, if we look at this vector of 3-star scores and the vector of 4-star scores, the average of the 3-star scores is 4.02, and the average of the 4-star scores is 3.88. And what this is saying is that even if the average review for 3-star and 4-star hotels are the same in general, by random selection, you might get a difference between, you select some random scores for the 3-star hotels, you select some random scores for the 4-star hotels. It's not that weird to get a difference of 4.02 versus 3.88. that could happen by random chance. It's going to happen around 24% of the time, this p-value of 0.236. Okay, so right now we don't have any reason to believe that the 3-star scores and the 4-star scores are different. Okay, what about the 5-star scores? Well, we can extract those values as well, and we can do a comparison. We can say, how do the 4-star scores compare with the 5-star scores? And when we do that comparison, we get a p-value of 7 times 10 to the negative 6. So, 7 divided by 1 million. So I guess 7 in a million chance. A very, very small probability, indicating that it is very unlikely to get a difference between 3.88 and 4.38. So, it doesn't seem super dramatic, but apparently going I don't know what that is. Going from 3.88 to 4.38, which is kind of a difference of 1/2 of a point, a whole 0.5 points, is a statistically significant difference. We're saying that this kind of difference just isn't going to happen by randomness, okay? Or is just very unlikely to happen by randomness. So now this would be akin to saying, I flipped a coin 20 times and I got 19 heads out of 20 flips, okay? If you get 19 heads out of 20 flips, I think you would be convinced that something is weird with your coin. Otherwise, how else do you explain getting 19 heads out of 20 flips? Because the idea of it being a fair coin that somehow by random luck produced 19 heads out of 20 flips seems a little absurd, because the random probability of getting 19 heads out of 20 flips just by sheer luck with a perfectly fair coin is really, really, really small, okay? And that's basically what we're saying. The random probability, the probability of getting this kind of difference by sheer luck just from kind of the random process is really, really small. So rather than concluding, is it possible to get 19 heads out of 20 flips? It's not impossible, but it's so incredibly unlikely. We say, if this were to happen, I get 19 heads out of 20 flips, I'm going to come to the conclusion that something's wrong with my coin. And so similarly, is it possible to get a difference of 3.8 versus 4.38 by random luck? Not impossible, but incredibly unlikely. 7 in a million chance. So rather than saying we were one of the lucky 7 in a million, we're going to come to the conclusion that the reason why we're getting this difference is because there actually is a difference between 3-star hotels or 4-star hotels and 5-star hotels. Okay, and then we can do a similar thing, and we can compare the 3-star hotels and the 5-star hotels, and we still get a very small p-value, not as dramatic, not as small as 7 in a million, but here is 5 in 10,000. Okay, so around 1 in 2,000, I guess. Okay. And so we're still going to come to the same conclusion, that we reject the null hypothesis. We say, there is a difference in ratings between 3-star hotels and 5-star hotels. Okay. All right. So that's where we left off on Monday. And I'm hoping this is starting to make sense, all of this hypothesis testing stuff. In this case, we had 3 categories: 3-star hotels, 4-star hotels, 5-star hotels. And so it's not too hard to do comparisons between each pairing. 3 versus 4, 3 versus 5, 4 versus 5. It's not that hard, okay? But what if we had, say, 6 groups? Category A, Category B, Category C, Category D, E, and F, right? And so, maybe we're not talking about hotel star ratings, but it's, I don't know, I don't know. You're comparing 6 brands of cars or something like that, or 6, you have 6 options for something, and you want to kind of compare these things. All right. In that case, how many pairwise comparisons would you have to do? You have to do A versus B, A versus C, A versus D, A versus E, A versus F, then B versus C, so on and so forth. There's going to be 15 comparisons. And that's a lot more, okay? And there are problems with doing a whole bunch of comparisons, in that if you do a whole bunch of these tests, you're more likely to encounter like a weird chance thing because of a weird chance thing, right? Here's like this little comic, I don't know if you ever visit this site XKCD, which does kind of like nerdy related comics and stuff. But here is it's an older comic where Minecraft was a new game at the time, so there's like references to Minecraft. But how long has Minecraft been around now? It's like over a decade, right? So, but anyway, it starts off with this woman coming in and saying jelly beans cause acne, and then they tell the scientists to investigate. The scientists return and they said, we found no link between jelly beans and acne, p being greater than 0.05. So again, our kind of rule of thumb is if the p-value is greater than 5%, it means we do not have evidence that there's a link between whatever it is that we're looking for. That we don't have evidence to reject the null hypothesis. And so so they say that settles that, but then they say, I hear it's only a certain color that causes it. And so they tell the scientists to run a whole bunch of tests. And so the tests try out, is there a link between this color jelly beans and acne, right? So they say and they come back and they say, we found no link between purple jelly beans and acne, p greater than 5%. We found no link between brown jelly beans and acne, p greater than 5%. Found no link between pink jelly beans and acne, p greater than 5%. And it goes through all of these different colors: blue jelly beans, teal jelly beans, salmon jelly beans, red jelly beans, turquoise jelly beans, magenta jelly beans, yellow jelly beans. All of these and ended up with p-values greater than 5%. So they say we don't have evidence of a link. They keep going: gray jelly beans, tan jelly beans, cyan jelly beans, they still have p-values greater than 5%. Here it says we found a link between green jelly beans and acne. Our p-value ended up less than 5%. Okay? And then they continue on with more statistical tests. No link between the mauve jelly beans and acne, beige jelly beans and acne, lilac jelly beans, black jelly beans, peach jelly beans, orange jelly beans. All of these things ended up with p-values greater than 5%. And maybe now that you see that they've ran a whole bunch of these different statistical tests, maybe we see a little bit of the problem is that for any one of these tests, the probability of something happening by kind of random coincidence, our threshold was if the probability of it happening by random coincidence is less than 5%, that's going to be enough for us to say it's an unusual thing. Okay, but if you run a whole bunch of these things, now the overall probability that you encounter a weird thing by random coincidence in total is much, much, much greater. Okay, so if I said, what's the if I flip the coin 20 times and I say, what's the probability I get 15 heads out of 20 by random coincidence? For that one instance, maybe it's only 5%. Okay, it's less than 5%, so it's not that weird. But if I do this a whole bunch of times, right? If I do 20 of these trials, and then one time I get 15 heads out of 20, okay, after a whole bunch of these repetitions, now you have to ask, like, is this suddenly proof that my coin is unfair? I wouldn't say so. Okay. But of course, what happens, with our sensationalized news, anytime we do find some kind of strange occurrence, that's going to be the first thing that gets published. Green jelly beans linked to acne, 95% coincidence, only a 5% chance of coincidence. And this, at its face, is true. There is only a 5% chance of coincidence. But we ran a whole bunch of these tests, and so anytime you kind of take your data and you just slice it up a whole bunch of ways, now you run the risk of encountering something a little bit strange by random coincidence quite a bit. Let me give you your first view quiz answer for today, which is the letter D. D as in dog. D as in dog. Okay, so what I wanted to continue on with is performing something called one-way ANOVA, okay? And so this is useful if you have multiple groups and you want to compare the means of all of the groups at the same time. So here I have 3-star hotels, 4-star hotels, 5-star hotels, and I want to compare all 3 groups simultaneously. Rather than doing 3 versus 4, 4 versus 5, and 3 versus 5, I want to just compare, 3 versus 4 versus 5 all at once. And I can do that with one-way ANOVA. And this can be generalized and expanded to any arbitrary number of groups. You want to have 6 groups, 10 groups, 20 groups, you can perform one-way ANOVA. You say, okay, I've got 20 groups, and I want to compare all 20 groups at the same time. Now, one limitation is that the null hypothesis, and maybe I'll have to add this, the null hypothesis is basically all the groups have means that are equal. Okay, and then if you reject the null hypothesis, that means at least one of the groups has a mean that is different. Okay, unfortunately, it will not identify which group is the group that has a different mean. Which group or which groups is or are the group with different mean. So if if you have 20 groups that you're comparing, it might come to the conclusion that your null hypothesis is all 20 groups are the same. It doesn't matter if you come from California or Alabama or Alaska or whatever, the average height of people in all of these states maybe is all the same. That's your null hypothesis. Is there a difference in average height from people from California versus people from Alabama versus people from Arizona or something like that? You might compare 20 states. And your null hypothesis is no, there's no difference. Okay? And then the alternative is actually at least one of these states has a different average height than the others. Okay? And the data might come back and it says, we have evidence that not all 20 are the same, at least one of them is different. And you go, okay, great, which one's the different one? Unfortunately, one-way ANOVA will not tell you that. One-way ANOVA just says all 20, they're not exactly the same, okay? But that, at least it'll give you a starting point that says, okay, well, all 20 aren't exactly the same. And then from there, you can kind of do some comparisons, okay? You'd probably identify like the shortest group versus the tallest group or something like that and just say, hey, are these different? So how do we go about doing something like that? We say AOV is for analysis of variance, which is what ANOVA stands for. ANOVA stands for analysis of variance, okay? Or AOV. And we're going to say, is the score in the Las Vegas data set? So again, we look at the score variable, which is this thing, okay? Is the score variable related to the hotel star variable, okay? Hotel stars. So, some of these hotel, have 5 stars and whatever. And so we do AOV score tilde, okay? We're saying, is scores explained by hotel stars? We're going to say our data comes from the Las Vegas data set. And it gives me this. What we actually want to run is summary of AOV on hotel stars. And in this case, this is our p-value. Now, there is a problem, okay? There is a problem, and that is in our data, the number of hotel stars that we have is stored as a 3, 4, or 5, okay? And when ANOVA sees a 3, 4, or 5, it thinks this is a number, okay? And it's true. It's a 3-star hotel, 4-star hotel, or 5-star hotel. But it thinks these are literal numbers that 4 is like 5 is bigger than 4, and 4 is bigger than 3, and 5 is 67% bigger than 3, and 25% bigger than 4, or something like that. And it thinks there's some kind of like ratio that can be used, right? Like if you buy 3 gallons of gas versus 4 gallons of gas versus 5 gallons of gas, you can kind of how much would the 5 gallons of gas cost? You take 3 and you multiply by 1.67 type of thing. So this is technically not the correct way to do it because hotel stars is a categorical variable. So So the initial problem, I'll say, hotel stars is a category and not a number. So if you have a variable that needs to be treated as a category, you have to turn it into a factor. Okay, so factor is the key word in R, okay, to turn a variable into a categorical variable. We use R's function factor. Okay, so you just take the variable, in our case hotel stars, and you just put it inside the function factor. And so, depending on your data, you might have something where you've got different categories. It might say like, I don't know, you might have like gender stored in one of your variables, okay? And it might say 0 corresponds to male, 1 corresponds to female, 2 corresponds to other, or 3 just corresponds to like didn't respond or something like that, okay? And if you leave it as 0, 1, 2, 3, then the way R is going to treat that is it's going to treat, 3 is 3 times bigger than 1, and 2 is twice as big as 1, and something like that, which is not how it works. It's just we have different categories here. And so you would have to take that variable and you want to turn it into a factor. You want to turn it into a categorical variable. So, again, depending on your data, you might need to do something like this. So here we're going to do AOV, score tilde factor, and then we would also run summary on AOV, score tilde factor. And here, we get the p-value is stored in this column. Okay, and you don't worry about what these other numbers mean right now. Okay, at this point in your statistical career, you don't have to worry about this. If you take Stats 101B in the future, that is the class that delves into all of the details on ANOVA. Okay, so ANOVA, I'll just say ANOVA is covered in much greater detail in the course Stats 101B, okay, which is design of experiments / ANOVA. Okay, those two kind of concepts go hand in hand. So here we end up with a p-value of 1 times 10 to the negative 5, and that is a small number. Which is less than 5%, and that indicates this variable hotel stars is statistically significant. It plays a role in the score that the hotel receives. Okay, and I guess again, an unfortunate shortcoming of one-way ANOVA is that it does not tell you which one is different. Is it the 3-star scores that are different from the 4-star scores, or is it the 5-star scores that's different from everything else? It's not going to tell you. From the other analysis, I think we can be confident that it's the 5-star scores that are different from everything else, but one-way ANOVA on its own won't tell you which scoring system is the one that's different. I know this is new and this might feel strange, and again, I guess I'm just kind of exposing you to a lot of these things. Hopefully, you'll have these documents as references, and you can say, okay, this is kind of what the professor did for this thing. Maybe we can apply it. And again, if you're not 100% sure, come to office hours, and I'm happy to try to help your group out. All right, I have a part 2, okay, for demo analysis here. So here I've already cleaned up the names and whatnot, okay? In this case, what I want to deal with one of the columns here, the hotel name, and some of the hotel name includes things like Circus Circus Hotel and Casino, the Excalibur Hotel and Casino. Other things don't have the word casino, okay? Monte Carlo Resort and Casino. And so what I want to do here is I want to see if the hotel name, if it includes the word casino, does that make a difference, you know, in terms of like hotel reviews and things like that? So what I want to do is I want to search for the word casino in the hotel name. You might have a data set, okay? I saw a group say they wanted to work with kind of this movies and TV based data set. And one of the columns is like genre, okay? And the genre column contains things like, oh, this is a drama, this is a comedy, this is a crime, and it might even be like part of multiple genres, okay? And so what you might want to do is you might want to say, okay, let's look at movies that are dramas, okay? How do you figure that out? How do you pull out? You can do something like string detect to extract out or to detect whether the word drama exists in this column, okay? Or, you know, if there's, you know, actor names or something, you could search for your, you know, one of your favorite actors, you know, I don't know, Tom Hanks, and you can search for a particular word. And so here, I'm going to use this function called string detect, str_detect. This is part of the tidyverse. And so what I'm asking it to do is I'm going to say, look at the column hotel name and detect if you see the word casino. And if you do, okay, string detect will return either a true or a false. Basically, a yes, I detected the word casino, or no, I did not detect the word casino. Okay. And because we're going to create a new column based on this, we're going to use the word mutate. Okay. So I'm going to take Las Vegas. We're going to say create a new column using mutate. And the values that go into the column will be whether we detect the word casino, in the other column, hotel name. Okay. And then after that, we're going to select those two variables, hotel name, and here I'm going to select the new column I just created, has casino, and then let's just kind of take a look at the resulting data here. So here we can see this is what we have, and we can see, okay, when it's Circus Hotel and Casino Las Vegas, casino is true. Has casino is true. Excalibur Hotel and Casino, the word casino shows up, that's true. Monte Carlo Resort and Casino, the word casino appears. Treasure Island Hotel and Casino, true. Okay, here we have the Tropicana Las Vegas, a double tree by Hilton Hotel. The word casino does not appear in the name, so here we get the word false, okay? Caesar's Palace, the word casino does not appear there. Now, Caesar's Palace does have a casino, okay? And so this is just if the name contains the word casino, not actually if the location. Now there are also hotels along the Las Vegas Strip that are hotel only places that do not contain a casino. So, you know, the Cosmopolitan Las Vegas actually does have a casino. I'm trying to think. I'm pretty sure the Trump Hotel is a hotel only and doesn't have a casino there. Hilton Grand Vacations also, I believe, is a hotel only and does not have a casino. Okay, so this column of has casino is strictly on whether the name of the hotel, I guess the official name listed in this thing, contains the word casino or not. And maybe that's not a good predictor. Maybe you actually want to go and like look up these hotels individually yourself. I think there's 24 hotels or something, so maybe it's not too much work to do. Okay, so in this case we created a new variable. Okay, but and here I just viewed it. If we actually want to work with it, we actually have to kind of save this back. So right now my Las Vegas data set still has only 20 variables. If I want to add a new variable here for has casino and I want to store that back into Las Vegas, I have to do Las Vegas mutate has casino, put that back into Las Vegas, and when I run this, what it's going to do is it's going to update my data set, and now I will have 21 variables. Okay, and I can click this, and now I have 21 variables. The last variable now is whether it has that casino or not. has the word casino or not in there. Sometimes you want to detect if it has one word or another word, and so you can use parentheses and a bar to indicate different words to search for. Okay, so Hilton and Marriott, I believe, are the same company. Or is it Hilton? No, Hilton is not part of Marriott. No. We maybe we want to, but just detect, because they're two major chains, and so we're going to say, is it a Hilton or a Marriott? Okay, and so we can go through this Las Vegas data set, looking at the hotel name. We want to say, all right, is this Tropicana Las Vegas is a DoubleTree by Hilton? Okay, so we want to say, okay, that one should show up true for it being Hilton or Marriott. We've got, what else do we have? Okay, Hilton Grand Vacations would be a Hilton hotel, and we got Marriott's Grand Chateau. And so in that case, we can detect Hilton or Marriott, all right? And so we use the vertical bar. We also need to kind of group the words together using parentheses. So this is going to say search for the word Hilton or the word Marriott here, right? And so here I'm going to go ahead and run this. Again, I'm not saving this variable per se. I'm just running it and just taking a look at the results. And so we could see, all of these things ended up with false. When it does detect the word Hilton, it comes back true. And when it does detect the word Marriott, so Hilton Grand Vacation comes back true, Marriott Grand Chateau comes back true. So these are just some tools that I want to give you as far as trying to detect certain words in a column. So if you have in your data, if you have a column that has text information, these are some of the tools that you have. And again, working with text is tricky and and comes with certain challenges. So if you are trying to work with text and you need help, again, don't hesitate to come to office hours, and I'm happy to try to give you little chunks of code that will help you get you on your way. Okay. If we look at certain variables, maybe we want to extract out certain, like the last two letters or the first three characters or something. This is not, we probably wouldn't want to do it for number of rooms, but you have certain patterns that can say, I want the last two characters, or I want the first three characters, or something like that. And so the pattern dot curly brace $2 will extract out the last two characters. And then the pattern caret dot curly brace 3 will extract out the first three characters. And so just to kind of show you the results here, I'm sorry, just having a stomach ache here. This will extract out the last two characters in this particular field. So in this particular field, number of rooms 3773. I don't know what use it will be to extract out the last two characters or something like that, but it's a possibility. All right. So if you're interested in extracting out the last couple characters of a certain field, that can be helpful, or the first few characters of a certain field, again, it can be helpful. So here we're extracting out the first three characters, and we can do that. So sometimes you have like a zip code, and the first digit of the zip code will kind of tell you what region. Generally, East Coast is have low numbers, and as you go from east to west, they climb up. And so in California, we start with a 9. The entire West Coast starts with a 9, but the entire East Coast will start with like 0, 1, 2, 0, 1 or 2. maybe a 3. I think 3 is starting to get a little bit more Midwestish. And that's what we have there. All right, you know what? I'm sorry. I'm going to go ahead and just call it just a little bit early today. And I'll show you some additional features, additional tools, and we'll start to look at some of the student groups data for future groups. Let me go ahead and give you. Have I given you any view quiz answers? Just one. Okay. The last 2 are the letters B as in bear, and A as in apple. B as in bear, A as in apple will be our last 2 view quiz answers. Okay, we'll just go ahead and end a touch early here, and we'll see you in your, if I haven't met with you, we'll see you for your project meetings tomorrow. Otherwise, we'll see you Friday.